This lesson was about the Indian square root algorithm. It's a couple of thousand years old, and it takes a geometric approach. In these Indian documents, they have what you see up here, this approximation of the square root of 2. And it's written in a very unusual way. That could have also been written as 577 over 408. And it's extremely close to the square root of 2, but it's not exactly the square root of 2. And I'm going to show you where this approximation came from. The basic idea is if you had a square whose area was equal to exactly 2, then the sides would all be equal to the square root of 2. So if I were to give you two squares that each had area of 1, sorry, these are drawn not perfectly. If I could somehow cut these up and reassemble them, I could reassemble them to a square whose area has an area of 2. The most obvious way to do that is to cut it like this and then reassemble those 4 pieces like that. Here's piece 1, 2, 3, 4. Or if I want to get fancy, so it is possible to, they call it dissection, to dissect these 2 pieces, reassemble them to make this, and these lengths will all be the square root of 2. But that doesn't help me get an approximation for it. So what the Indians did is had a very clever idea. Rather than cut the 2 squares up to make a perfect square of size of area 2 that's shaped like a square, instead they cut up this second piece this way, and they assemble it like that. And what they get here is an L-shaped thing, not a square. This L-shaped thing has dimensions 1.5 by 1.5. It has an area of 2, and it's this L-shaped thing, which is not a square. And what this means is that from this we could say that the square root of 2 is somewhat less than 1.5. One way to think of that is that, another way to say that is that 1.5 squared would definitely be bigger than 2, because 1.5 squared would be this entire square, including this kind of missing piece there. So, however you want to think about it. Another way to think about it is if I were to sort of melt down this thing and turn it into a perfect square, this sort of missing square thing would get filled in, and in that way it would make the size a little bit shorter. We'll get to that another time. For now, the approximation that square root of 2 is less than 1.5. And that's going to be true if I could ever make one of these L-shaped things, which is basically a square with a square sort of cut out of it. Some people call that a gnomon. I think that's the way you pronounce it. Well, that's not the only way to cut up 2 squares. Another possibility is to do this thing. We cut the second square up into 4 pieces and reassemble the four pieces plus the original piece here. But when that happens, we end up with 1/3, and this guy ends up being 1/6. That's one of these little guys. Ends up being 1.5 again. So this is actually the same solution, because 1/3 plus 1/6 equals 1/2. So that's not a better approximation. What we need is a more ingenious way of splitting up these 2 squares in such a way that the area is still 2, of course, because I'm not throwing out any of the pieces. And the thing is, I can measure it, I can calculate the actual length and not just say, oh, it's the square root of 2, something with fractions that's only approximate. And the key is to get this whole here smaller. And this is the way they came up with it. So if you take the first square and put it here, and you cut the second square into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces in this very clever way. So piece 2A goes here, and 2B goes here. Those are thirds. And then this other third, I split that, take a third off of that. So that little guy is 1/9. That's piece 2C. And then somehow these 2/3, the 8 of them, fit around the edge of this square. Each of those things is 2/3 times 1/8, which is 1/12. So this thing here definitely has area of 2, because we haven't thrown out any of the pieces, but its width is 1 plus a third plus 1/12, which is actually 1 7/12, or 19/12. And that's a pretty good approximation of the square root of 2. Notice how this resembles the first couple of terms, 1 plus 1/3 plus 1/3 times 4, that we saw in the beginning. That is over here. Oops, I just realized I made a mistake. 1/3 is 4/12 plus 1/12. This is actually 1 5/12, which makes this thing 17/12, and 17/12 is 1.416, which is a good approximation to the square root of 2. So sorry about that little error. In the next lesson, you will learn how to get even more approximate or more accurate answers, namely, where does this term come from, and could we even do better than that, even better than this 577/408? And the answer is yes, and you'll learn how that works. Thank you.